Thank you, guys. I appreciate it very much. Those of you that don't know me, I can't see you. I'm used to giving these live, so a little bit different. And I used to encouraging questions and walking around with my arms flapping stuff like that. So this is going to be a little bit new for me, in that I'm going to have to sit in a chair and try to make this reasonably entertaining, I guess. But anyway, name's Kyle Fickler. I'm a director of business development with Aeromotive. Been with the company in some capacity for pretty much since it started in '94. But love doing this kind of stuff for the simple reason that I look at it as an opportunity to learn from you guys, and that's one of the reasons we're here, and encourage the Q&A at the end. So what we've done with the help of Jake and Greg and the rest of the R&R staff is put together 6 of these, and rather than doing the whole line, a lot of times how I characterize it is we try to bring the SEMA show and the PRI show to you in terms of new product, but generally we break it up into equal thirds of just physics, just general fuel system tech, if you will, that applies to other lines that you might sell or represent. Then a third, roughly, of new product, and that's where the SEMA PRI component comes in. And then a third, our legacy product, our A1000, that was our first pump going back in '94, part number 11101. It still sells like crazy, and it will always be part of our line. But at the end of the day, that 11101 is on its, I believe, 7th different motor or motor program, if you will. And so those products continue to evolve. That pump, for example, I mean, it's more durable. It flows better. It's just a better all-around piece than it was in 1994, or than it was in 2000, or it was in 2010. So that's generally how we do this. So this format's going to be a little bit different, in that we're trying to give more in-depth bite-sized pieces. And this one, late model in-tank solutions, is a pretty interesting one, because it's an area, obviously, as we are seeing street-driven horsepower levels escalate rather quickly, to where we've found a lot of opportunity, and I know you guys as distributors and jobbers have a lot of interest in. A lot of it driven by changes in how we build cars. Obviously twin turbo LS, E85, things like that. Those are trends that are still, it seems like, gaining momentum. There was a point in our history when we thought E85 use had plateaued and started to taper off, and in reality that was just a period in time when the E85 use changed from Subarus and 4G63 Mitsubishi to Camaro, Mustang, and Silverado. A lot of trucks and SUVs. So that being said, I'm going to give you just a couple minutes. I don't know who all's on, but just touch on the history a little bit, and then we'll dive into some of the product-oriented stuff. So you guys know our history. That's Steve Matusik, our founder. Currently runs NHRA Pro Mod. His, about 100 feet from me, there's everything from super gas car that his dad originally built and raced, to a Roush Yates powered dragster, and a variety of other cars that he's piloted over the years. But Steve was down in Gainesville waiting for the season to start, and like the rest of us, found out, I think, that Friday that his season wasn't going to start, although he did race some the week before. So those of you that know, I'm raced for more than 30 years, which, being that I'm only 38 years old or something like that, something I'm pretty proud of. But that picture's not going to go away for a while. That was last June in Topeka, Kansas, and had a pretty good day that day, and looking forward to getting out there again and putting the helmet on and having a little fun. I know all you guys are too. So,
hey Kyle, you're not sharing your screen.
Okay. What are you seeing now?
You.
Just
your
me?
ugly mode.
Oh my gosh, we got to fix that. Any suggestions?
The present now button.
Sorry, guys. Let's see, share. Okay, share your entire screen. Let me hit cancel again. Share, present now. One more time here. Seeing that now, Jake?
No, sir.
What the heck is going on here?
And if you want to just send them over to me, I can share them while you're talking too.
Yeah, I want to figure this out. It's still just the count or just me?
Yep.
Go back to meeting. Sorry, guys. They always said I should have been an IT guy. I think they might have been pulling my leg. It's a big file. Present now. Want me to try a window? That was your entire screen?
Yeah, you can try it.
We had this working so well earlier.
Yeah.
Anything?
No, sir.
Let's see. I see Gary and Adam, so I can see that kind of stuff. Present now. Is there something you want me to close and try again? I'll do what I did before. I'll click on that.
Yeah.
That work?
Yep, you're good now. You'll just have to present your PowerPoint.
We're getting a handle on this. A practice run. I'm glad we had that. It would have been really bad now.
Yeah.
Okay, now there it is. Is that better?
Yes, sir. Thank you.
Thank you. So it back there a couple. So that kind of brings us to where we're at in some of this late model development, and an area where we have made a lot of progress in the past 12 months is on our GM truck side. That slide in front of you now, this was really brought about by our friends in Oklahoma and Texas primarily. And I always tell the story this way. One neighbor had a Camaro, the other one had a Mustang, and some guy with a Silverado, decided, hey, I'm gonna whip both their butts. So pretty soon we're throwing turbos on these pickups, and E85 is very popular in that part of the country. So they started looking for fueling solutions. And along the way, how we did it, and this kind of shows you, the earlier slides about, how we're racers, and that's how we develop solutions. This fits right in with this program for the simple fact that we knew there was a need, we knew we could provide a solution, but it was really tough getting data on the tanks on some of these late model trucks. And so how we developed this program was basically having customers send in their own tank, and we would build a bill of materials around putting the system in their tanks. And it took a period of time but we came to learn things like HD tanks are an inch deeper than half ton, than 1,500 tanks and things like that, to where there just wasn't a data resource out there. So we had to do it the old school way, and that was bring tanks in and stuff them full of product, figure out how to use the OE lock ring, how to package it all together. And so what you see there is everything from single 340s up to triple 450s, and the horsepower ratings are just insane. But it covers Silverado 99 through 04, has a selection, and then 05 through 18. And this has turned out to be really good business. What I wanted for you, those of you that are familiar with the program, what I wanted to update you on, when we originally released this product, we didn't have a solution for the fuel level sending unit. We have since solved that. Spoke with Matt yesterday. He has 5 different brackets. They don't break down just into those 2 groups of 99 through 18. There's actually 5 different brackets that he has drawn. We'll start manufacturing here real soon, that will allow the end consumer to install that fuel level, the factory fuel level sending unit in all those kits. And that's been the one thing that has been holding us back a little bit in that program. And I know those of you that have sold the product and rep the product are pretty aware of that. So Matt's been working on that solution. That's in place. Don't have part numbers yet, and there's still some nuance to figure out on how we're really going to bring that to solution or to fruition. But that's an update since PRI, since most of you have, been engaged with that product most recently. So big news there, and I think we'll just see that program continue to go forward. So I got to change this, guys. Hang on. I got to see what you're seeing. Let me try this again. I didn't lose you, did I, Jake?
No, you're still good.
Okay. So that's where truck's at, and you're going to see some of that continue through. So this goes back, and I'll go through this real quick because we're real strong right now in Chevrolet truck. What we have on the car side for Chevrolet is still our A1000 and Eliminator kits. Some of you are familiar with these numbers, but if I've learned anything over the past few years, a lot of people have forgotten about them. Just wanted, if nothing else, just to put them out in front of you and let you know that they're available. They're still a good solution. Same thing on the Ford side. A1000 Eliminator kits up through 17 on the Ford side. One thing I want to point out that it'd be, I guess, on your bottom right-hand side, that little T fitting. When we first released that product, that little bit of engineering and science there, for me, was a pretty good learning experience because it was our first, I think, really successful attempt in utilizing the OE jet siphon technology to where we did it right and didn't trigger a bunch of trouble codes, things like that. So same circumstance there. Those products are still available, but a little bit of a teaser pick here. That's not our typical product picture, as you can imagine. What that is, I think that's a 15 tank, and you'll notice Matt has it cut in half. So that's a saddle tank that you find in a modern Mustang, and but you'll kind of see the lengths he has gone to as he's building these new modules for the Mustangs. And what that allowed him to do is that's a borescope, the red and black device there on the right-hand side. You can see he's measuring voltage and temperature and all kinds of things. That particular tank had triple 450s in it. But one of the things he was doing is he was sciencing that out, engineering a solution, was really paying a lot of attention to the factory jet siphon and how it works. And some of that is just visualizing what the return fuel looks like as it comes out of returns through the hat, but also how that factory jet siphon functions. So got to give the engineering team credit. They were able to utilizes our Apex jet siphon valve because of its self-wetting function, but all the in-tank jet siphon plumbing is all factory. And that's an area from an engineering standpoint takes a little bit of extra effort. I mean, even though we're known for, universal high flow, high pressure systems, typically, when we get into these late model applications, one of the things we really pride ourselves on is being able to retain as much of that factory architecture as we can, for a couple of reasons. I mean, factories spend millions of dollars developing a lot of that stuff. If you don't utilize it, you're almost guaranteed to just setting off all kinds of trouble codes. So that area in this tank with a saddle tank is something that need to give the engineering team a lot of credit for. Much like that Chevrolet truck program, this Mustang program, we use everything but the single 340. And that was just kind of driven by the fact that the factory pump's pretty good. Probably wasn't much of a business case to be had for a single 340 in that application. But you will see that we do dual and triple 340s, single, dual, and triple 450s, dash 8 ORB ports. So for the E85 guys, gives them an opportunity to, step up in a plumbing size, to where they can support the horsepower. And as of yet, we don't have pricing on this, but Matt and the engineering team has assured me we should be shipping these modules in Q2. They do use the factory lock ring. I would suggest replacing the factory gasket. When you do replace it, just I think it's a single-use piece and just probably good practice overall. But engineering's been teasing me a little bit that the price point, the retail price point on these is going to be favorable compared to our primary competitors out there. So, but like I say, they're still in process of finalizing some pricing, the bill of materials. So stay tuned on that. I think that'll be a real exciting program for us. And those of you that have been around for a while know that we can be kind of a Ford-centric company at times, or certainly that's our reputation, even if we don't intend it to be. So to be able to come into the Mustang market and make a big splash with this kind of product is pretty exciting.
Hey, Kyle,
Yep.
I missed this, but Dar asked if about GMC Canyon or Chevy Colorado stuff. Have you heard any development items on that at all?
I lost the first. What was the first part of the question, Jake?
Any development on like the Canyons or the Colorado trucks?
Not that I'm aware of yet. The one I did leave out was Trailblazer SS. We have a system for it as well, and I know one of the fuel level sending units fits that. But let me make a note of that. Something that I didn't ask Matt, but if there has been something done, I'm unaware of it, and I don't know that we've even had a tank in house for that. Are we seeing? I guess how I would follow up with that too. Are we seeing a lot of performance use? I know a lot of off road and but are they running E85 and building more power? That'll probably be a follow-up that we'll let you come back on, but I'd be curious about that too. I don't know that we know much about that tank. So as we move kind of from brand specific stuff, there's the last 8 or 9 days, I guess, on the tech lines, it's really cemented in my mind what we're seeing primarily on the GM side, but with consumers starting to install the GM direct injection motors in cars, whether it's LT1, LT4, LT5. And I'm going to present this in a little bit more of a looking forward way, but there's also an element of this that is looking backward that I think Brett has been confronted with a lot. You guys are familiar with the Bladder Baffles that goes in our Phantom kits. Just leaving that up there for that pick. It's available a couple different ways, either a Phantom 450 or Phantom 340 with the Apex already installed. Or we can retrofit the Siphon kit, the 18706 can retrofit on anything except 450s, just not enough room there. I'm going to talk about this for a second. That was a video, the one slide I passed. I can come back to that, but I want to share a little more information with you first. The reason I mention this in connection with direct injection is what's become really apparent is actually these two things kind of fit together. People that are relying on an OE fuel pump module to pulse width modulate let's say our Gen 2 tank, for example, or our competitors, in-tank solutions. As more of them get out there, it's starting to become apparent that part of the OE technology that a lot of our competitors are overlooking is the environment we're putting that pump in tank in if they don't use a regulator. So basically what they're doing, they're creating a returnless system in both these scenarios, both the DI and the pulse width modulation, even when it's not DI. They're using the pump without a regulator and controlling pump speed to the extent where these pumps are getting really unhappy. What ends up happening is they slow the pump down so much, and some of the numbers that we've put together here recently slowed it down to where you might see a pressure range from 40 to 70 psi as an example, but they're doing that without bypassing the fuel. They're just doing it by slowing the pump down to extreme levels. What ends up happening when you do that is the pump basically stalls. It's stopping, starting, stopping, starting, and at really low pump RPM, if you will, gets to the point where amperage draw just starts to escalate because the thing kind of starts a ratchet action, even with turbine style pumping mechanisms. And those of you that have sat in on these seminars before know that we we talk a lot about the benefits of the turbine style because it's being a single piece pumping mech. It doesn't start to ratchet like multi-piece do. That's the benefit of it, and it is a tremendously good solution and easy solution when the consumer uses it with the regulator. What ends up happening when they're doing this returnless stuff is it gets the pump in a real unhappy zone. As I said, amperage draw goes way up, heat goes up, complicated by the fact that in a lot of these scenarios at lower fuel levels, you have the super hot pump, and at low fuel levels, most of our competitors don't have a solution to keep that pump wet at all times. And particularly in direct injection applications, that thing takes a gulp of air. It pushes the air between the pump and the DI pump, and there's nowhere for that air to go. It just creates this, internal vapor lock in that system that is different than what we see in a port injection system, if you will. So that's kind of where the crossover's at between the port injection side and the direct injection side. So the reason I'm throwing this all together, these two different topics, together with Phantom Apex is, and a lot of this experience has come from Brett. He has been able to go back in situations and utilize Phantom Apex. And the reason it solves two of the issues. By using the bladder baffles with the Apex, we have that gallon of fuel, and I'm going to see if that video works. We have that gallon of fuel at all times in that bucket. There we go. So what you'll see if you haven't seen this video before, this works off the pressure side of the pump. So it basically creates a venturi that draws a gallon a minute through that hose. You can locate that hose with magnets, so it doesn't matter if it's poly tank or an aluminum tank. What you'll notice now at the top of the screen, it's overfilling that bucket. And so this valve is a really simple but really trick little piece. It has like a P-trap built into it so it doesn't siphon and empty the bucket. So imagine that in your tank. So if you're an eighth of a tank of fuel, you'll notice in the video that the fuel's half-inch off the floor of our aquarium there. But we have 6 or 7 inches of column height of fuel in that bucket, force feeding itself into the pump. Imagine that inside your tank. So that's how we're able to get around the gulp of air for overgeneralizing, but the gulp of air that has really become an issue at low fuel levels in both direct injection and pulse width modulated returnless systems and port injection. So keep that thought for a moment. Remember, we have the bladder baffles in that bucket as well. Going the wrong way. So that's one advantage to employing the Apex in these situations. The other one is because how we use the Apex on the pressure side of that pump, the pump doesn't slow down like it would if you took that same pump in a normal pulse width modulated scenario. Where in effect, so the pump's working to keep that bucket full. It's not paying 100% attention to what the engine needs because it's kind of splitting its capacity, if you will. So by keeping the pump at a higher RPM than it would be if they just slowed it down on the pulse width modulation side, we're keeping the pump happier. So it's not getting into that spot where the pump stalls. Higher RPM, amperage draw stays lower, heat stays lower, and it's not going to pump air in a low fuel level situation. So one thing I want to mention is you guys know that have been through this drill before. The Apex takes about 15% of the capacity of the pump, and the numbers work out to where if you're in that 700 EFI forced induction 850 NA, if that's your neighborhood with a 340, it forces you to step up to a 450 just to cover those same numbers again, roughly. So just keep that in mind. It's one of the reasons we're promoting that the Phantom 450 as well. Just spoke with a guy this morning who has a dual Phantom, and I think that's what we're looking at for his application for some other stuff. So just as a reminder, again, it fits everything but the triple pump setups. And I think as we start to see more of these, particularly GM DI motors end up in older muscle cars and trucks. I had a C10 guy yesterday putting a LT1 in, and really kind of brought this home for me about what a trick piece engineering that Apex is. So a little bit of a teaser here too. We next up, and Matt's done some work on this already, and the engineering team has, is a Mopar solution. The Mopar's crate engine program seems to be real strong. Hellcat has driven a lot of that. We're seeing the swaps and everything. Traditional muscle cars. You guys know we have our Hellcat Gen 2 tanks with the 525 liter per hour pump. We are working on and have a tank here in house, Challenger Charger 300 tank, that will go through that same program that the GM trucks and the Ford Mustang did. Matt, as of yet, hasn't seen a huge obstacle in that kind of fitting that same program to where, I don't know if we'll offer a single 340, but certainly dual 340s, single, dual, and triple 450s, I think is the plan there as well. He thinks it'll move pretty quickly, or the engineering team does. So looking forward to that. Not at a point where we can put a date on it yet. But as you see those, builds come together, just keep that in the back of your mind. One corollary we've seen is the engine parts, the hard parts guys have really found a strong market in late model Hemi. So that's made this a bigger priority. Camaro, we're not quite as far along on. I would expect that same kind of program there as well. A little bit more of a geometry challenge, I think, in the Camaro in terms of locating the pump, locating the fuel level sending unit relative to the top cap. So it's on our radar. It's behind the Mopar solution we'll offer. So stay tuned on that as well. And then brushless update. This has been something I think that it's the success of our brushless in-tank program, our universal stuff has brought this question to the forefront. And that is where we at on a brushless 3.5, 5.0, 7.0 for these late model cars. Bigger challenge than what we've presented with you today with the, the duals and triples and stuff like that. And the simple fact that the pump assembly, the stacked height is much greater than what we can do with these dual and triple pumps. There is room in the tanks for the most part, although not the room that we would like to see. So it's a space constraint, just not enough real estate there to do everything we want to do. That combined with the fact that in a lot of these instances, we know we're going to need a remote or divorced brushless controller somewhere off the tank. Doing so, though, presents some cooling issues with the brushless controller. So certainly still on the engineering list. I would say probably top half of the list. But with the engineering resources we have, it's probably not something we'll see in the near future. But certainly striving to see sooner than later. So just a quick update on brushless.
You're at about 30 minutes, Kyle. So
okay. How about that then?
I love it.
Sorry, guys, we had some IT issues there in the middle, but hopefully provided some value on the tech side. Any questions I can answer?
Everybody's muted, so if you want to ask any questions, just the bottom, there's the microphone that you have to turn on.
Me turn on?
No, everybody else. If they want to ask questions. And then just in the chat box, I have the form to fill out if you want a free T-shirt for watching through all this Kyle Fickler training.
Man, we might have to offer more than a T-shirt. Maybe an invitation to happy hour tomorrow. How about that?
Yeah, Kyle's paying.
Virtual happy hour.
Yeah. Let's see here. You had a couple questions. Uh, Josh asked, any advantage, disadvantage to running multiple in-tank pumps versus single in-tank versus single pump, liter per hour being equal?
Great question. There was a point in time where I didn't think I would ever see this company offer a triple pump. Matter of fact, I probably made that statement publicly a few times. um, so from an engineering standpoint, um, yeah, but it's so anytime you have three of anything, you can just imagine what the amperage draw is at. I mean, any of our trifectas, just depending on the pressure, you're going to be between 45 and 60 amps. That's an awful lot of amperage draw. And we'll cover it more I think this afternoon segment, but you start getting up around 60 amps. I mean, then you're in that neighborhood of you're running 4 gauge or 6 gauge wire, stuff like that. That's kind of what, from an engineering standpoint, kept us from doing it for a long time. The other side, from the consumer side, is that when you have three of something, you're leery of one of them failing, right? Because you just tripled your component count, if you want. That being said, as a consumer, then you tend to favor, hey, that 3.5 or 5 gallon a minute brushless spur gear looks like a real attractive option. So I hear myself say that. The big advantage of the triple 450s is they're super quiet. That 5 gallon a minute spur gear, even in true variable speed, it's going to be pretty noisy back there. So if if you have a late model, Mustang and you want it, until you're 100% throttle or 70 or 80% throttle, if you want it to remind you as much as the day you drove it off the showroom floor, the spur gear is not going to let you do that. So in that scenario, the triple 450 or dual 450 or something like that might satisfy that need. When we're getting to these power levels, and keep in mind, we're at gas forced induction 2400 on that triple 450. So, insane horsepower capacity. But let's say that midpoint of 1800 horsepower or something like that is going to be the new normal at some point. I'm not sure that there's a continuum there to where, going back to our history of trying to fuel 1,000 horsepower street cars with a continuous duty pump seemed those cars were unicorns in the day, and now they're pretty common. So as we move farther up that scale, I don't know where the consumer is going to land a year from now or 2 years from now. In 94, they really didn't care how loud the fuel pump was, just as long as it supported the horsepower. Now that they're taking a $80,000 car off the showroom floor and expect the air conditioning and everything else to work, my hunch is that they expect the fuel pump to be quieter, which is a friendlier option for that triple 450 option. Granted that the spur gear pump in tank will be considerably quieter than the inline version, but you guys know that stuff. So there's no easy answer on that. We're confronted with all of them. I think all those different realities, noise, the electrical side in terms of amperage draw, how much heat it produces. Our true variable speed brushless spur gear, though, I think will fill, especially for that E85 guy, will fill a void that right now nobody else is doing in that market. So wasn't trying to be politically correct there. Just all those they're all kind of realities that we're confronted with.
Yeah. Ricky asked about multi-pump safety pump failure solutions.
Yeah, in terms of one failing and the consumer doesn't know it.
Yep.
Yeah, I don't know if there's, it's a reality, I guess. I mean, we try to circumvent that by, every pump, assembly being tested. We, wet flow every pump, and I mean, it's the unfortunate part is with a really good regulator, assuming the pumps are staged, one pump turns on, then 2 and 3 turn on, or however it's set up. If the regulator's really doing its job, you may not pick up a pressure drop that, if you're relying on fuel pressure as kind of a safety device. that would overcome that. Now, if there may be some point in the power curve to where it would, but we take a lot of pride in our regulators too, to where even like with the big brushless stuff where we're at low flow, it's 30% of max flow. If we're doing our job right, the customer shouldn't see, or the engine shouldn't see a change in fuel pressure through that flow curve. And if you look at it, I mean, that's basically what we're doing. We're running on, 1/3 of that pump. So it's a complicated question. There's what I do like is there's guys out there with like Motec systems and stuff like that. What they will do, and I've seen this work well in the off-road world, is they measure amperage draw on each pump. And if they see amperage draw spike on, let's say, one of the 3 pumps, you could set up some kind of an alarm or alert in the off-road world where they have redundant systems. If they see amperage draw spike up, even because of like a contaminated filter or a plumbing issue, something like that, then it automatically goes to the second pump, to the redundant pump. So I'd be curious to hear. That question makes me think that Richie probably has a practical solution as well, but I can see an ECU to where you could set up an alarm just based on a big change in amperage draw for sure.
Yeah, he also asked about multi-pumps with pulse width modulation.
Yeah, it's kind of more of the same there, I guess. I don't see, or if there is a big issue with that, I'm not aware of it, but it would, it brings back to what we're doing with that Phantom Apex. Keeping in mind in those triples, you have a primary. So at that, you have a primary and then the 2 auxiliaries, at least how we've been putting them together. It's you run on 1 pump and then 2 and 3 simultaneously. You could certainly stage them other ways with an aftermarket ECU. So that being said, if the benefit of that is that when pumps 2 and 3 come on, the engine should be at max pressure. You shouldn't be in that scenario where you're trying to make all 3 pumps behave as if you only had 1 pump. So as you go through that, throttle tip in and you go from low demand to high demand, the fact that the engine actually requires or is requiring more fuel kind of solves the problem, just because we don't have the pump slowed down that far.
Jason asked about staging the multi-pump so they don't all run all at once and only kick on when you're under boost.
Yeah, so a lot of different ways to do that. That's one of those areas where I think there's just a variety of ways. I mean, you can do it, off vacuum, you can do it off boost, you can do it off TPS, you can do it off, we've got some guys now using like a 1-bar map sensor in a real high boost application, so that they're even doing that on the brushless spur gear to where at a 1-bar map sensor you're going to be at full pump real early in the boost curve, just barely in the boost when it turns that one on. So I think some of the aftermarket ECUs probably give the consumer more options than what the consumer fully understands, So we'll talk about that some in our brushless session, I think later today too. Just different things we're seeing out there that probably apply just as well in that multiple pump scenario.
All right, that's all we got for questions, unless anybody else is asking away.
Once again, guys, I really apologize for the IT issues we had there. Really thank you for your patience and your interest in our product line and willing to join us today. And man, I just ask you all to stay safe and you're all smart people, do the right decisions. We'll get through this together and look forward to seeing you guys at the racetrack here real soon.
Yeah, and Jason just asked 8204 S10 tanks. Tank setup?
I'm trying to remember. Will our what'd you say, 82 to what year?
04, I think.
04. So that'd be a steel tank. I'll have to make a note of that for Matt. I'm trying to remember if our 340 even fits fits in there. I know the return line's too small for the 340, so that's probably an ideal scenario for a Phantom, one of the variety of Phantoms with a, -6 or -8 return line, depending on if he's going to carburate it or EFI. And my guess is it's LS swap, and probably the easiest direction to go on that's just a Phantom rather than something that locks and cap. Although I could ask Matt if that top plate's the same, it may be a pretty practical solution.
Awesome. Yeah. So next training session people want to join is at noon about filter style or return style regulators and talking about filters.
Sounds like fun.
I cannot wait, Kyle.
Hey, I work hard to make fuel filters sexy. It's tough to do.
All right. We'll see you at noon then.
Thank you, guys. I really appreciate your time today. Appreciate you joining in, and stay safe.